So today and the rest of the week, we're going to be looking at scatterplots and how we can use scatterplots to create what's called a line of best fit and come up with an equation for that line of best fit that can be used to create predictions about future values that aren't on the scatterplot. So oftentimes, statistical studies are done where data is collected on two variables instead of on one in order to establish whether there is a relationship between the two variables. This is called a linear regression analysis. So taking a look at number one, we have a survey was taken of 10 low and high temperatures in Fahrenheit in the month of April to try to establish a relationship between a day's low temperature and high temperature. So we're going to take those points and create a scatter plot for part A. So it says construct a scatter plot of this bivariate data set on the grid below. So we're going to graph each one of those corresponding x and y values. So we have 26. Now these are in twos. So this is 22, 24, 26. So we have 2649. And you're going to have to estimate a little bit. Try your best. 2850. 3057. 3254. 3460. 3558. 3764. 3866. 4163. 4572. So our graph would look something like that. Oh, my 72 is up too high. That should be here. Then the next step says to draw a line of best fit through this data set. So I'm going to make this pretty specific so that it works out the right way. We want the line to go through the points 30, 54, and 40, 66. I do that so that when we algebraically calculate the line of best fit, it actually works out. So I'm going to take a different color to show you where those points should be. So 30, 54 is here, and 40, 66 is here. So then you're going to take a straight edge and very neatly draw your line of best fit through those 2 points. And you can see that that line runs pretty center to all the points that we plotted in blue, the points that created the scatter plot. So that's why it's called a line of best fit. It follows the trend of the data that was created by the scatter plot. Next, we're going to determine the equation for the line of best fit. So there isn't much room here, so try your best to squeeze it in or move it over to the side. So we have the 2 points that we use to create this line. So we're going to put them in a table, and we're going to start calculating the linear function that would go through those 2 points. So 54 to 66 is a change of 12. 30 to 40 is a change of 10. So 12 over 10 is our slope, or 6/5 rather, if you were to simplify it. So I'm going to have y equals 6/5 x plus b. Now I have to solve for b. So I can plug in one of those 2 points that we just calculated. So 54 equals 6/5 of 30 plus b. So 54 equals 30 divided by 5 is 6, times 6 is 36, plus b. And if I subtract 36 from both sides, b winds up being equal to 18, making my line of best fit y equals 6/5 x plus 18. So we don't see the y-intercept on our graph because of the break here, But if this line was to continue down, that would probably be that should be crossing at what is about 18, being the y-intercept. So now we have that line, and we're going to use it to make some predictions. So it says, use your line of best fit to estimate the high temperature for a day in April, given that the low temperature was 42 degrees. Illustrate your answer on your graph. All right, so they want 42 degrees as the low temperature. So we're going to plug that in for x. You can do it below. I'm going to do it over on the side so I don't lose my graph. So part D, we're taking our line of best fit, which is y equals 6/5 x plus 18. And we're going to plug in a low temperature of 42. Low temperature is the x, so it goes in the x. So y equals 6/5 of 42 plus 18. So y equals 42 divided by 5 times 6, which is about exactly 50.4, plus 18. Adding the 18, we get y equals 68.4. And it says to illustrate your answer on your graph. So that point 42 and then 68.4 would be over 42 and then up to 68, about 68, 2, 4, 6, 8.2. And look, it's right on the line. So it's estimating that point and it winds up being exactly on the line. Okay, so if the low temperature is 42 degrees, we can predict that the high temperature will be about 68.4 using the linear model we came up with. Okay, then part E says, would you characterize the relationship between low and high temperature as a positive correlation or a negative correlation, and then explain. And there you want to write that this is a positive correlation. It's a positive correlation because it has a positive slope, and as low temperature increases, high temperature also increases. Okay, so then from there, on the back or the next side of your notes, we are going to be talking about how sometimes when there's correlation, there isn't necessarily what's called causation. Okay, so for the next part, we have two variables can have a strong relationship with one another, as seen on a scatter plot, but might not have a causal relationship. A causal relationship exists when the change in one variable actually causes the change in the other. So now on your own, you're going to go through number 2, and you're going to talk about whether each of those scenarios definitely causes the other scenario. So you're going to talk about whether it's causal or not, and answer the questions that follow and go formative. And then you're going to try number 3 as well.